All right, new unit. Looking at ratios and proportions. So something you may have to do is simplify these ratios and proportions. So again, I'm just going to look at the coefficients, and I see that I have a 15 and a 12. So I know, hey, they probably have a 3 in common. I could reduce this down to 5/4. And again, your units are still going to be centimeters squared. So it's important to see that you need to make sure that you're using the same units, or else it's not going to be proportional. So like in this case, I'm not using the same units, but I know that there are 5,280 feet in 1 mile. So what I'm going to do is I'm going to set up my proportion. So again, this says 1 mile over 20 feet. I'm going to go ahead and change this mile into feet by doing, okay, miles is on top, so I'm going to want to cancel it out, and I'm going to cancel it out by writing 5,280 feet on the top. So if I just look at my units, miles divided by miles cancels out. So I can multiply across and say 1 times 5,280 feet over 20 times 1. And so when you do 5,280 divided by 20, you're going to get 264 feet. Maybe like over 1 foot. Last one we can simplify here. Again, pounds to ounces. 1 pound equals 16 ounces. So I'm going to turn these pounds into ounces. And this one, I'm just going to do 3 times 16. Which is going to give me 48. So I'm going to say that I have 48 ounces over 10 ounces, which we could simplify that. If you divided it by 2, you'd have 24 over 5. Yeah, there we go. Find the ratio of the length to the width. This is my length. This is my width. So the ratio of the length to the width would be 10 meters over 320 centimeters. So again, notice the difference here. Again, there's 100 centimeters in 1 meter. So this would really be like saying 1,000 centimeters over 320 centimeters, which we could reduce it to, see here, 100 over 32, which could be reduced as well. Divide it by 4. 25 over 8. All right, using some numbers, AB is proportional to BC. We can see that right here, and it's 2 to 7. So for every 2 ABs, we're gonna have 7 BCs. The entire thing is 36. Find AB and find BC. So I'm gonna say again, everything I do, I'm going to keep part to whole relationships. So I'm going to say, okay, am I looking for part of it, or am I looking for the whole thing? And I was given this relationship of 2 to 7. Now, I don't know what AB is, but I do know that the whole thing is 36. So we could plug this in and say, okay, 36 times 2 equals 7 times x. I'm going to solve this. 36 times 2, 72. Divide by 7. And it's not going to come out as a whole number. That's okay. But I'm going to say that this is about 10.286. So that's going to be my smaller point right here, 10.286. Couple ways I could find BC. Again, looking for this section right here. If I know that AB is 10.286 and the whole thing is 36, I'm just going to subtract 36 minus 10.286. And get 36. 25.714. So this blue or this green part right here is going to be 25.714. Okay. The measures of the angles in triangle ABC are in the extended ratio of 1 to 2 to 3. Find the measures of the angles. So I like to think about it, okay? This is 1x, this is 2x, and this is 3x. Again, getting my ratio right here, but I know that triangles always add up to 180. So I'm going to do 1x plus 2x plus 3x equals 180. This is going to give me 6x equals 180. And when I solve my left and my right side, I'm going to get x equals to 30. So my smallest angle right here is 30. My second angle is 2 times 30, which is 60. And then my third angle is 3 times 30, which is 90 degrees. Cross multiplying. Always cross multiply to try to solve these. If you only have one unknown, you should be able to cross multiply. It's when you have multiple unknowns that it gets tricky. 5 times 16 is 80. So I get 80 equals 10x. Divide by 10 on the right, divide by 10 on the left. X is 8. Again, make sure you're writing these out carefully. You don't want to make a silly mistake. Multiplying here, multiplying here. 1 times 3y equals 2 times parentheses y plus 1. 3y equals, use the distributive property and multiply into each term. 2y plus 2. Get your y's together. Y equals 2. All right, the geometric mean. So again, make sure when you're taking your notes, you write this down. The geometric mean of two positive numbers, A and B, is the positive number x that satisfies. So this is what the formula that you really got to make sure that you have. So again, if you think about cross multiplying, you get x squared, and then you get A times B. But if you want x, or if you want to solve for the geometric mean, then you have to multiply them and then take the square root of it. So to find the geometric mean, I'm going to say, okay, I have A. So this is like my A value, and this is my B value. So I'm going to say 12 over x equals x over 27. When I cross multiply, I'm going to get 324 equals x squared. Now I have to take the square root on both sides. And we want to, it says simple radical form, so we have to simplify this. So let's think what numbers go into 324. My guess is that 4 goes into it. So if I think about, I want to split this up into 4 times what? And I actually believe that that's going to be 81, which works out super nice because, I mean, we can do the square root of 2 times, the square root of 4 is 2, the square root of 81 is 9, and so our answer is actually a whole number. The square root of 324 equals 18. So that's one way. I wasn't sure off the top of my head, but I was able to problem solve it by using what I know. I had a hunch that 4 would work. 4 did work. It was actually 4 times 81, which we know is the square root of 4 is 2, and the square root of 81 is 9. All right, set it up again. 18 over x equals x over 54. When I multiply 18 times 54, I get 972 equals x squared. I'm going to take the square root of both sides. And this one, I don't think I will get a nice number. But, again, if I'm trying numbers, I say, okay, our perfect squares, does 4 work? No, I don't think so. Does 5? Well, 4 would work, but 5, no. 9, I think 9 works. So I'm going to try 9. And I'm going to say, all right, this is like saying 9 times 108 is equal to the square root of x squared, and x cancels out. So all you're left with is x. We know that the square root of 9 is 3. So now I have 3 times the square root of 108. I bet I can split up 108 again. We're going to say that 4 times 27 is the same thing. So 3 times 2 times square root of 27. And I don't think, we can keep going. So again, I'm doing it step by step because I wasn't sure. I know that this is the same as 9 times 3. So when I finally am done, I'm going to get 3 times 2 times 3 is 18 square root 3. So the faster way would have been, let's see here, 18, or they would have had a larger factor. So we were factoring out smaller numbers. We could have found a larger factor and done it faster. All right, last one here again. Multiply 16 and 18. 16 times 18, 288 equals x squared. Take the square root. I'm trying to figure out what perfect squares go into 288. I had a hunch that 16 would work. It did. It was 16 times 18 equals x, because this cancels out. 4 square root 18 equals x. I know that 18 can be written as 9 times 2. So 4 times 3 times the square root of 2 is 12 square root 2.